the wing component. Okay, by using the parameters, the 2D parameters and some wing specific parameters like span, chord length, which type of aerofoil, okay, and other parameter with respect to the wing, whatever needed to design or to create a wing, that we have completed, right? So now we'll be going to the next component, or we'll be creating a fuselage. It is 3D fuselage. Okay, into 3D fuselage. Okay, so we'll be creating a 3D fuselage by using 2D fuselage parameter. Okay, suppose if you have the parameters like the length and the cross section, okay, and other parameters related to the fuselage. If you know all the parameters, the dimensions, okay, then you can import your fuselage parameters and the particular dimensions, and you can create a 3D fuselage. Okay, or you can say a 2D fuselage parameter, like this what we have. Okay, here this is a 2D case, right? So we'll be designing a 3D fuselage by using given parameters. So parameters, it may be like this: the length, the design cross section order, and the nose type, first and last cross section, okay, and the cross section at each and every point, like splitted point, 1 2 3 or 4 5 6, like that. And with respect to that, which type of cross section you are placing at that particular section. Okay, so that will be done in this today's class. Okay, so before I start this topic, or before I create a 3D fuselage by using the 2D parameters or by using the fuselage parameter, it's a little bit important to recap the things what we have covered in the class 16. That is the different type of fuselage. As we know, we have different fuselage, that is tubular, barrel, box, lobe, okay, and other different types. And with respect to that different type of fuselage, okay, we can able to see the cross sections also, right? Slab side, round, oval, ellipse type, rectangular type, okay, fuselage type. So like that we have different types of fuselage and the cross sections, okay, like semi monocoque type or monocoque type. And even I have covered the design steps. Okay, suppose if you want to design a conventional aircraft, then these are the following design steps for fuselage. Okay, so here we have all these points. These points are the fuselage design steps for a conventional aircraft. Okay, suppose if you know payload, aircraft mission, and aircraft configurations, then with respect to that, you can design a fuselage. And before designing the fuselage, you have to well known with these parameters, like identify and list the fuselage design requirements, determine the number of crew members, determine the number of flight attendants, okay, especially for passenger aircraft, and also determine the number of technical persons for cargo aircraft, okay, and establish a human size and target passenger. Also you have to select the layout, that is the side view, front view, top view, which means the 2D view, okay, and the conceptual sketch, what you will be covering, that is very important. Also, you have to determine the instruments for the cockpit and design the cockpit, establish the fuselage optimum length to dia ratio, okay, and design the passenger's cabin, okay, design the cargo and luggage components. So like this, we have different parameters for different fuselage. Okay, some fuselage will design especially for commercial purpose, and some fuselage will design especially for fighter aircraft, and some fuselage will design for helicopter. Right. So like that, as per our requirement, will be change our fuselage design and will obtain the particular design. Okay, like this we have. So this fuselage, this is for commercial case, and here we have for military case. Like, so these are all things I have discussed, right? Just I'll recap by showing the slides. Okay, even you have to well known with this dimension. Suppose if you are planning to design commercial kind of aircraft, okay, and of course you have to design the fuselage for the commercial aircraft, fuselage length, fuselage nose section length, cockpit, other components, okay, with rear fuselage length, how much you want to keep, what is the door length from the rear side and from the nose side. So these all dimensions, if you know, then it's very easy to design your particular fuselage. Like these all dimensions and the parameters. So these all things I have discussed. Okay. So once you all know, then as we know, real aircrafts and the assembly of the fuselage can be done, right? And inside the fuselage, this is how they will place the components like a seating arrangement, okay, and luggage arrangement, cargo components. Like that, they will split each and every component based on the splitting. They'll arrange like this, okay. They will split each and every component like cargo component, seating arrangement component, okay, nose section component, a rear section component. Like that, they will split each and every component, and after splitting and after mm, covering parts, or after splitting each and every part with respect to that splitted part, they will place the particular components like a seating arrangement or cockpit system, okay, or APU system. So as per the required place, they will place the component required location, okay. So this I've already discussed. So now I'll be showing how to design 3D fuselage for using a given parameter. Okay. So today we'll be covering a simple fuselage. Okay. Next class I'll go for complicated parameters. Okay. Because it's a first class, so that's why let's go with the basic fundamental. So here you have the question. What is that? Design a 3D fuselage by using given parameter in the OpenVSP software. Okay, so length is 35 unit. Why I have given unit? Because here in the OpenVSP we don't have particular measurement like meter, centimeter, kilometer, okay, or millimeter like that. Just you have to type the unit or the number. So suppose if you have typed 35, you can export your number whatever you have typed, suppose like 35 that has to be converted or that has to be exported in a meter or centimeter, and then you can export, okay, you can export that 35 unit as per your required dimensions or as per your required unit, that may be a centimeter, millimeter, or feet, okay. So that's why I have just mentioned the unit, okay. Design cross section order, okay, that is monotonic. So in the design cross sections order, you have to use the condition that is monotonic condition. And nose type. This nose type for this fuselage, okay, for this 2D case is given. That is the pointed nose type, which means this nose type what we have first and last, okay, front side and the rear side, the nose type what we have, that should be sharp. Okay, first and last cross section, that should be pointed with sharp. Okay, cross sections 1, 2 and 3, condition is given. Cross section, you have to take 3 cross sections of this overall fuselage. The length, what we have, 35 unit. Okay, for this 35 unit length fuselage, we have to split the cross section, okay, into 3, 1, 2, 3, and the whatever cross sections will split, okay, all 35 unit length fuselage, that cross section type must be a ellipse type with its parameters, that is height must be 4 and width must be 3 unit. So these are all the given conditions to design a 3D fuselage. Okay, or these all are the parameters. Okay, 2D parameters or fuselage parameter. So by using this parameter, we have to design a 3D fuselage by using our OpenVSP software. So now we'll go to OpenVSP software. So here I have the software icon. I'll just double click on this. As we know, as soon as we double click on the software, we'll get two windows simultaneously. Okay, the first window and the second window. First window, that is our OpenVSP window or vehicle sketchpad window, and the second window, that is the component window or geometrical browser window. So here, by using the geometrical browser window or component window, now we have to add the fuselage. Okay, because we are here to design the fuselage. Okay, so our aim is what we have to design the 3D fuselage, right? So that's why we have to add the component. Which component? The fuselage component. Okay, just select the fuselage component and add it. As we know, okay, what we know that as soon as we add the fuselage which we get in the VSP window, that fuselage is the default fuselage with some default parameters. Okay, so we have to alter the default fuselage parameter as per our required parameter or as per our required dimensions or as per our required condition. Okay, so here we have our conditions or the fuselage parameters. So we have to input all these parameters in this component. Okay, this component window. So which component window? Here we have the fuselage component window. So in this fuselage component window, we have the general option. Okay, XForm, subcomponent, design parameters, skinning, and cross sections. So here, first one we have to use the length. So now what we have to do? We have to change the length. To change the length, you have to come to the design parameter. Okay, so length, the default length of this fuselage is 30 unit. So as per our requirement, here we have to use the 35. Okay, length we have to maintain 35. So instead of this 30, what we have the default fuselage length 30, we have to change this 30 to 35 because our requirement what we have the 35, right? So we will use our requirement or our parameter fuselage length that has to be 35. So I'll just type 35 and I will enter. As soon as I enter, you can able to see the changes in this default fuselage length. See, right? Initially, see, suppose if I type 10 instead of 35, then you can able to see the changes, right? The length of this default fuselage has been changed from 35 to 10. Okay, but currently we should use 35 because according to our parameter, the fuselage length is 35. Okay, so just I will use 35 itself. I will not use 10 or 30. I'll just type 35 and I will enter. Okay, so this is done. And design cross section order. Design cross section order. This is our second parameter is given, that is monotonic. So I have to use this parameter also, that is design cross section order. It is monotonic. So design cross section order is here. Design policy. Under this design policy, design cross section order monotonic. So default it is monotonic itself. No need to change this design policy cross section order monotonic into loop or free order. Okay, just maintain same, that is monotonic, because here we have the same parameter design cross section order, that is monotonic. Okay, so that's why I just maintain design policy or cross section order monotonic itself. Okay, and no cap and all, no cap type, that is sharp. Okay, so I'll just change. Okay, 9 into sharp. First and last cross section. So fourth parameter we have about the cross section. So we have to come to cross section. About skinning, nothing is given, right? See in this, I have not given anything. Okay, about skinning, I have not given anything, right? There is nothing about the skinning, so that's why just leave this one as it is. Okay, here in this parameter, okay, in this design parameter, okay, I have not mentioned anything about the skinning, so that's why just leave this tab as it is, the default thing. Okay, instead of the skinning I have given something about the cross section, that is first and last cross section condition is given, that must be pointed, which means your first and last cross section that must be pointed. So I'll just come to cross section. Here we have zeroth cross section. Okay, that is first and the last cross section. First cross section, second, third, and fourth. Okay, and I'll call this zeroth as the first cross section, and fourth one I'll call it as last cross section. Okay, so that's why here first and last cross section parameter is given, that must be a pointed type. Okay, so here the cross section type is pointed itself. Okay, initial cross section and the last cross section, the cross section type is pointed. So even you can have a preview. that is pointed. Okay, last one is also pointed, and the first one or the zeroth cross section, that is also pointed. But whereas the first, second and third, this one is the initial or first one and the last one. Okay, or else we can call this one as zeroth cross section and last fourth cross section. So in between this zeroth and fourth cross section, we have three more cross section. That is first cross section, second cross section, third cross section, and the last fourth here is that. So first and last are just to avoid the confusion, I'll just change that first into 0. Zeroth and last cross section that we have to maintain pointed. So it's pointed itself, right? And in between that, what we have the three cross sections. This one, 2, and 3. That three cross section, what we have, cross section 1, 2, 3. The cross section type must be a ellipse type with height 4 unit and width 3 unit. Okay, so now we have to come to cross section 1, cross section 2, and cross section 3. Okay, so we have to change the cross section type, and we have to maintain a cross section type at section 1, 2, 3. Ellipse type cross section we have to maintain with height 4 unit and width 3 unit. Okay, so by default cross section 1 is ellipse itself, cross section 2 also ellipse itself, and cross section 3. Okay, the cross section type what we have. Okay, at section 1, 2, 3 default cross section is ellipse itself, and as per our requirement that is also ellipse itself. So that's why I just maintain the same. But as per our requirement, the height of that ellipse is 4 and the width is 3. Let's check. By default we have the same or not. Height is 3 and width is 2.5. Default value here we have 3, that is height, and 2.5, that is width. So what is our requirement? Our requirement is 4 and 3, which means height of that ellipse type cross section, that is 4 and width is 3. Okay, so height, I have to change this 3 to 4 and I'll enter, and width I'll change 2.5 to 3 and I'll enter. Okay, so that is what our requirement now. Parameter what is given here, that is height 3, height 4 and width 3. That's why I have changed. Okay, and I will jump to second cross section. Okay, as soon as I jump to second cross section, the cross section type is ellipse itself, right? Cross section type second and third also ellipse with same height and width. With same height and width, in the sense height must be 4 unit and width must be 3 unit. So that's why I'll change the height 3 to 4 and I'll enter. Similarly, I'll change the width 5 to 3 and I will enter. Okay, second cross section done. Similarly for third cross section. Okay, cross section type what we have, the third cross section, that is ellipse, right? Cross section type, the third cross section, that is also ellipse with same parameter, ellipse parameter, that is height 4 and width 3. So I'll change the height of the third cross section 3 to 4 and I'll enter, and 2.5 to 3 and I'll enter. So yes, this is done. Okay, so according to the given parameter, we have generated or we have created the fuselage. Okay, so if you want, you can share this fuselage. And you can change the material. Now currently default material is that you can change default into aluminum, okay, or other required type. So I'll just now I'll maintain the default itself, and I'll use that view, top view. Yes. Yeah, so this is done. As per requirement, we have created a 3D fuselage by using given parameters. So we have used all these parameters, okay, and by using these parameters, we have designed the fuselage. Yeah, so here we have top view, ISO view, side view, and front view. Okay, so yeah, so we have used the simple parameters, design parameters, and we have done with our fuselage. Okay, which means we have designed, we have created a 3D fuselage by using the given parameters. So in the next class, we'll go for complicated parameters. Okay, so this is all about today's topic. All of you just practice and design your required fuselage. Okay, thank you to all. We'll continue in the next class. Okay, thank you.
Okay, thank you, sir.
Okay, thank you. Bye.